Now, direction based. This is the use case. So the first thing that happens during the planning session, assume that you have seen your last year profit, but you do not know what would be the revenue. You do not know what would be the purchase, transportation, and advertising forecast, but you kind of know what should be the min and max thresholds. So those will become your constraints. Secondly, you have the constraints with you and you would like to see whether using the constraints of these variables or drivers. So these are the drivers of your planning because they are editable. So they are independent variables right now, and profit forecast is your dependent variable. So you would want to now maximize the profit forecast. This is where direction based optimizer solver is going to be used. You go to planning tab and you've got the optimize option here. Right now, you cannot select it because it says, please select a formula cell to optimize. Click on that. Profit forecast is a formula measure where the column and the row aggregation was selected as formula. So the moment I click the total profit forecast, optimize option is enabled. Now I can optimize individually at any level of the hierarchy by dimension, but I'll stick to the total. I'll say optimize. Now here it says, what's your objective? We've got target, which will be used for target based optimizer. We've got maximize and minimize. These are the direction based optimizers. So I'll click on maximize. You have the option to see the formula, validate this in case if you think that the formula is incorrect. You can stop here and go back and correct your formula. Then you have the variables to update. Now, these are your independent variables. You've got revenue, you've got purchase, you've got transportation and advertising forecast. Now you click next, and this is where you add constraints. So I'll have constraints for revenue forecast. Let's say 78 million should be my minimum revenue and 80 million should be my maximum revenue. Observe that the scale is intelligently understood. If I write M, it understands that this is million scales. Now I'll click apply. Next one is purchase forecast. We'll have purchase with 21 million as minimum and 24 million as maximum. Apply this. Third one will be transportation forecast. Let's get 750K intelligent scaling and maximum will be 1.5 million. Let's apply this. And then we click add again for the fourth variable. And this one is advertising forecast. Company is interested to invest at least 4.5 million and maximum 9 million. We'll say apply. Now, the best way to use an optimizer is to ensure that you have constraints in all your variables. Because even if one variable is without any constraint, then there is a high possibility that that specific variable will have a particular change or simulation automated by the optimizer, which probably will look like impossible to achieve. So always try to give constraints to all the variables that are being used for optimizer. And then you have the run option. I'll click run. It says maximize objective can be achieved to maximize 50.58 million can be achieved. Your purchase forecast can become 21.55 million. Your advertising forecast can become almost 5.9 million. Transportation, you go to the lowest, which is 750K, and revenue forecast can become 78.79. Now this is total. So the moment I hit apply, the changes will happen on the total values, and then a self weight of that measure will be used to propagate the values towards all the connected dimensions. We've got region and country. Now, before I click run, or let's say apply, I have this set parameters option. So I'll just hover over my mouse on the information tooltip. It says higher the strategy, more aggressive and unstable the results will be. Tolerance, I'm saying that I can say yes, or I'm ready to accept the values with 0.1% plus minus tolerance, right? You can go up to 20%, right? So this says 0.1. I'll just retain 0.1 here. And there are a number of iterations. So how many iterations or how many changes took place in the backend in less than 1 second? So this has got 1,000, 2,000, 5,000, 10,000 iterations. So it tried to find out a permutation combination at cell level for 2,000 times. Now, what happens next is simply apply this, and you would see that the profit forecast has changed to 50.58 million, revenue forecast, purchase forecast, transportation forecast, and advertising forecast. They have all changed. The values have been propagated based on self weight, and you've got a new forecast margin, right?